Graph the curve given by the parametric equations x equals t plus 1 and y equals t squared minus 2 over -3 to 3. So let's go -3, -2, -1, 0, 1, 2, and 3. And we're going to plug those into the t value for x. So we have -2, -1, 0, 1, 2, 3, and 4. And then 9 minus 2 is 7, 4 minus 2 is 2, 1 minus 2 is -1. That's -2. 1 minus 2 is -1, 4 minus 2 is 2, and 9 minus 2 is 7. So now we want to make sure that we don't use those to graph. -2, 7, -1, 2, 0, -1, 1, -2. And then it should be symmetric because this is a parabola. So we're going from left to right. So we make the little arrows. Eliminate the parameter t and write the pair of parametric equations in rectangular form. We got to get rid of the parameter. Well, we need, let's go with this. Let's go x minus 1 equals 2t. So t is 1/2 x minus 1/2. Now we'll plug that in for this t. So y is equal to 6 times 1/2 x minus 1/2 squared. Over here, let's add 8 and divide by 4. Oh yeah, let's not do the fraction. Let's just go cosine of t equals x plus 8 over 4. And then y minus 7 is equal to 2 sine of t and divide by 2. Sine of t is equal to y minus 7 over 2. Now, sine squared plus cosine squared is 1. So x plus 8 squared over 16 plus y minus 7 squared over 4 is equal to 1. Find an explicit formula for the nth term of the arithmetic or geometric sequence. Explicit formula for, so a sub n. So a sub n is equal to, oh, this is what, adding 3? Adding 3, so that's arithmetic. So -5 a sub 1 plus n minus 1 times d times 3. So -5 plus 3n minus 3, so 3n minus 8. Over here, r is -2. So a sub n is a sub 1 times r to the n minus 1. Find each sum, find the 25th partial sum of this right here, which looks like we're subtracting 5. We're adding -5. The 25th partial sum, so s sub 25 is 25 over 2 times a sub 1, 20. But now we need a sub 25. I need the 25th term. So a sub 25 is equal to a sub 1 plus, well, not n minus 1. We know how many there are. Plus 25 minus 1, and we're adding -5. So grab a calculator. Let me set this up so I don't have to, so I can use the calculator. There we go. Let's slide this over. Slide that down, and away we go. 20 plus 24 times -5. So the 25th term is -100. So that goes there. Well, now we have 25 divided by 2 times, well, it's going to be -80. So -1000. Here, that's linear, which makes this arithmetic. We need s sub, if we go 28 minus 15, that's 13 terms. So there's actually 14 terms. S sub 14 is equal to 14 over 2 times, the first term is 30 plus 3, it's 33. The last term is what we get when we plug 28 in. So 2 times 28 plus 3. So the last term is 59. So we need 7 times 33 plus 59. 644. Find each sum. A sub 1 is 7, n is 4, r is 3. Well, this is going to be geometric. So find a sub 1, 4 terms. So s sub 4 is equal to a sub 1 times 1 minus r to the n over 1 minus r. 7 times 1 minus 3 to the 4th. And we'll divide that by -2. So 280. Well, this is infinite. That is infinite. So if we take 3.2 divided by -8, we get -0.4. Now, 3.2 times -0.4. All right, so we're multiplying by negative. So r is -0.4. Now, the absolute value of that is less than 1. So this series converges. This infinite series converges. S is equal to a sub 1 over 1 minus r. So -8 over 1 minus -0.4. So let's go -8 divided by 1 minus -0.4. So negative 5.714. Can that be a fraction? Let's go math, turn it into a fraction. -40 over 7. This is really -40 over 7 in case they have the fraction on the test. Find the specified term, S sub 15. So the so the sum is 300, a sub 15 is 35, and find the common difference. All right, well, a sub 15, let's do this. We know a sub 15, and that's equal to a sub 1 plus 15 minus 1 times d. So we really need a sub 1. Well, the sum is 300, and that's 15 terms over 2. A sub 1 plus, and then a sub 15 is 35. So we can actually use this formula to find a sub 1. So let's take 300, and we're going to divide by 15 divided by 2, which is what, 7.5? And then we can minus 35. So a sub 1 ends up being 5. So from this formula, a sub 1 is 5. Now we can plug that in here and find the common difference. So 35 is equal to 5 plus 14 times d. So 30 divided by 14. And I guess we can just go with the fraction on that. 15/7. So the common difference is 15 over 7. If S sub 6 is 186 and R is 2, find A sub 1. So the sum is 186 equals A sub 1 times 1 minus 2 to the 6th over 1 minus 2. So let's go 186. We're going to multiply by -1. So I'm going to get that -1 over here. That's negative 186. And then we'll divide by 1 minus 2 to the 6th. And is that a fraction? Is that a nice fraction? 62 over 21. So A sub 1 is 62 over 21. Use the graph of the right to find each value for 12 through 15. F of 1 is right here at 3. Limit as x approaches 1 is right there at 2. Limit as x approaches 3 from the right. That's at 1. Limit as x approaches 3 from the left is up here at 4. Evaluate each limit algebraically. Be sure to show work on this one. So let's see if we have 2 times 4 plus 2 plus 12. So 8, 10, 22. Here we get 0 over 0. So let's do the limit as x approaches 0. Let's take out an x. We have 2x squared plus 3x plus 10 over x. And that eliminates the problem. So then when we plug 0 in, we get 10. Number 18, limit as x approaches -2. I actually wanted this to be -3. Change it to -3 on your sheet. That way we get 0 over 0 when we plug it in. We're forced to factor this. That's probably what it's going to be if this appears on the final. We got x plus 3, x squared plus, oh, actually this has got to be minus, right? Same opposite, and then always plus. So that better be minus, and then plus 9. And then this will be over 2 times x plus 3. So we get rid of the problem, and we get 9 plus 9 plus 9 over 2, 27 over 2. Here, if we plug in 0, we get 0 over 0. And so we have to multiply by 9 minus 2x plus 3, square root of 9 minus 2x plus 3. So limit as x approaches 0 of 9 minus 2x minus 9 over x times square root of 9 minus 2x plus 3. So limit as x approaches 0 of the 9s will cancel. The x's will then cancel. So we get -2 over square root of 9 minus 2x plus 3. So now when we plug in 0, we get -2 over 3 plus 3, -2, 6, -1/3. Determine whether each function is continuous at the given x values. If discontinuous, identify the type of discontinuity as infinite, jump, or removable. So is it continuous? 4 minus 4 is 0. Yeah, that's continuous because it's the point to 0. Plus that's a parabola. It's nice and continuous. 7 over 7 minus 7, that's 7 over 0. So we have a discontinuity, and actually this one is an infinite discontinuity because we can't really get rid of that problem. It's not removable at all. We have a vertical asymptote there. All right, this one, let's go f of 1 is 2 over 1 minus 1 minus 2. So 2 over -2, -1. So this one is continuous there. And then this one, f of 2 is, oh, dang it, I really wanted this to be, let's go with -1, because I want you to see something that could actually be on the final. Now, does this cause this to be 0 over 0? So 0 over 1 plus 1 minus 2. Yeah, 0 over 0. Okay, I wanted that to be -1, so it reflects what could be on your final. So this becomes x plus 1, x minus 2, x minus 2, x plus 1. So those cancel, and now we can plug -1 in, which is 1 over -3. So this is a removable discontinuity at x equals -1 if you make it -1. Now with 2, f of 2 is just 3 over 4 minus 2 minus 2. That is actually 3 over 0. This is an infinite discontinuity because you can't get rid of that problem. That problem did not cancel out. Here we get the point 1, 5, and here we get 1, 0. So we have a jump discontinuity for this one.